In this video, we are going to see about a CPU scheduling algorithm called shortest job first scheduling. So this scheduling algorithm, it depends on the burst time of each and every process which we have. So what it does is it will just see to the process which is having the shortest burst time, and the process which is having the shortest burst time will be given the CPU to execute. Okay, that's what it says. The process that requires the CPU for the shortest period of time will be given the CPU to execute. So if the CPU burst of two processes are same, if the burst time of the two processes are same, in that case, how we are going to solve that problem? So if something happens like that, in some scenario, if you come across two processes that are having the same CPU burst time, then in that case, you have to use the FCFS scheduling algorithm in order to break that time. Okay, so in your SJF's algorithm, it works in two modes, that is your preemptive and non-preemptive mode. So preemptive is nothing but, so whenever you have a higher priority process comes in, the process that is currently executing will be thrown out, and the process that is having the highest priority will be given the CPU to execute. So that's why it is called as preemptive. Non-preemptive means even though whatever the priority it is not going to listen to it. It will just execute whatever it is executing at that particular point of time, and then only it will take the next process to execute. So this particular shortest job first scheduling is also called as shortest next CPU burst algorithm. So in this, we are going to see some problems, how this shortest job first scheduling works. First, we will see one problem with non-preemptive mode and then with zero arrival time. So in that case, how this is going to work, we are going to see. So as you see here, you have been given with a set of process. So P1, P2, P3, and P4, and they have given their burst time. Okay, each and every process is having its corresponding burst time. So as I have told you earlier, your SJF depends on the burst time. Okay, just sees to the burst time. According to that, it is going to act. And then what we have is the arrival time. So as you see here in this example, all the arrival time is 0 here. Okay, there is no difference in the arrival time. That means all the process are arriving at the same time. So all the four processes will be just waiting to get the CPU. So in that case, now the algorithm decides which is having the shortest burst time. According to that, it will give the CPU. Okay, so as you see, all the four processes are right now in a queue. Okay, it is right now in a queue waiting for the CPU. So as of we know, SJF, it depends on the burst time. It will take the process which is having the shortest burst time and gives the CPU to that particular process. So we need to draw the Gantt chart first. So we are going to draw the Gantt chart. So the first process to come in will be your P4, because P4 is having the shortest burst time. Okay, so P4 will come in first. It starts executing from 0 because the arrival time is 0. From 0 it starts and it gets executed till 3 milliseconds. Okay, it gets executed till 3 milliseconds. Once this is over, once your P4 process is over, once again, we are going to see which is having the least burst time. So as you see here, P1 is having the second least burst time. So P1 will be given the CPU. Process P1 will be given the CPU. So until 3, it is executed. Up to 3 milliseconds, it is executed. So 3 plus this 6. So up to 9 millisecond, your P1 will execute. After your P1 completes this execution, right now it come and see which is having the shortest burst time. So P3 is now having the shortest burst time, and now P3 will be given the CPU. P3 is getting the CPU and it is executing for another 7 milliseconds. So 9 plus 7, it will be 16. Okay, it will be 16. Up to 16 millisecond, your P3 will execute. And finally, the process to come in will be your P2. So now the P2 gets the CPU and it executes for 10 milliseconds. So from 16 to 26, this will execute. Okay, 16 plus 10, it will be 26. So this is what we call it as the Gantt chart. So once you have drawn this Gantt chart, the next column which we are going to find will be a completion time. So the completion time of each and every process we need to find it out. So as you see here in this, from this Gantt chart itself, we can able to find out the completion time. So as you see for P1, when it is getting completed, P1 is getting completed at 9 millisecond. So your completion time for the process P1 is 9. And what about your P2? P2 gets completed at 26. And P3 gets completed at 16, right? It gets completed at 16. And your P4, it is getting completed at 3. Okay, so the completion time we have done with. And the next one which we have to find is the turnaround time. Okay, turnaround time. So for this, we have a formula. So as you, if you go and see the previous video also about the FCFS, I have shared about that formula. So once again, we will see here also. For getting the turnaround time, we need to know the completion time as well as the arrival time. So if we know, if we have the completion time and arrival time, we can able to find out the turnaround time. So it is the difference between your completion time and your arrival time. So this is the formula to calculate the TAT, that is the total turnaround time. So for the process P1, your completion time is 9 minus your arrival time is 0. So it will be 9. And for P2, it will be 26. And it will be 16 for P3. And for P4, it will be 3. Okay, now the TAT is done. So once the TAT is done, we need to find out the waiting time. So in order to find out the waiting time, we need to have the values of turnaround time and burst time. So as you see in this particular table, we have the turnaround time as well as we have the burst time. So we can able to find out the waiting time of each and every process. So the formula here is, it is the turnaround time minus the burst time. Okay, minus the burst time. So as you see here for process P1, turnaround time is 9 and the burst time is 6. So 9 minus 6, it will be 3. And same here, 26 minus 10 will be 16 and 16 minus 7 will be 9, right? And then 3 minus 3 will be 0. As you go and see in this diagram also, you can able to find the waiting time. So as you see, P1 waits till 3 millisecond. After, by the 3rd millisecond only, it is getting the CPU to execute. Okay. So as you see for P3, it is 9. And for P2, it is 16. And for P4, it is 0. Because P4 is the first process to come in. At the 0th millisecond itself, because P4 is having the smallest burst time, it is given the CPU immediately. That's why the waiting time is 0 for P4. Okay, so this is how we have calculated. So once this is done, we need to find out the average waiting time. How we will find out the average waiting time? You have to add everything divided by the total number of processes. So here the total number of processes is 4. So how we will do 3 plus 16 plus 9 plus 0 divided by 4. Okay, so if you add and divide it, you will be getting 7 milliseconds. Average, this is called average waiting time. So your average waiting time is 7 milliseconds. Same way, you have to find out the average turnaround time. Okay, so how you will find out? You have the values of each and every process turnaround time. So add everything divided by the total number of process. So 9 plus 26 plus 16 plus 3 divided by 4. So when you divide it, it will be 13.5 milliseconds. Okay, so this is how you have to do the SGFS, SJF algorithm with zero arrival time. Okay, this is non-preemptive. So depending upon the process, whatever the process is executing, it will just execute and go. But the only thing is all the process are arriving at the same time. That's why it is directly going and seeing the smallest burst time and giving the CPU to the process that is having the smallest burst time. In the next video, we'll be seeing with different arrival time, same non-preemptive mode of SJF with different arrival time. We will see it in the next video. Thank you.